Hi. So welcome to Communicating Test Automation ROI to Business Stakeholders. My name is Omar Galeano. I'm a quality engineering principal from Slalom Build. And my wife and I moved to Japan from Seattle last August. And we love to hike. So I posted this picture from our first hike, which was at the top of Takao-san. The caption says that it's a high ROI hike because ROI means return on investment. And we saw some very nice views at the top, spending not too much time and energy to get there. First, some quick notes about Slalom. Slalom is a global consulting firm focused on strategy, technology, and business transformation. We're located here in Tokyo with our office in Toranomon. We have over 11,000 employees, 1,200 clients, and 41 offices across Asia Pacific, Europe, and North America. And we partner with over 400 leading solution providers, including AWS, Salesforce, Microsoft, and Tableau. So in the next 15 to 20 minutes, I hope that you'll learn what makes up test automation ROI, or return on investment, and how best practices and anti-patterns can affect ROI, and then take home a free tool to help model your ROI. And I'll share the download links at the end, so please stay with us. Okay, let's get going. All right, so in a software project, there can be many stakeholders. Some are technical and tend to focus on things such as infrastructure, architecture, and tooling. On the other hand, others are business facing and may or may not have a technical background. These tend to care about business constraints such as cost, schedule, and scope. In their world, time and money are investments. They want to know what software will cost and what they can get back in return. They want to know what their ROI will be. Now, test automation is software. It's software written to test other software, and it too is an investment. For example, it takes time and money to build or buy automation tools and to design, write, and maintain tests. These tests are called regression tests. They help us to find when features that used to work are broken by later code changes. Stakeholders often agree that automation sounds like a good idea, but may still hesitate to pay for it. For these, we can explain why manual regression testing alone is insufficient for many applications. In an agile project, new features are built each sprint, and regression testing is done on old features. Over time, we have more and more features that can break with new code changes, taking more time to regression test our older features. In this example, by sprint 9, over 90% of our testing time is now spent on regression testing. Eventually, it can take days or weeks to finish regression testing, or worse, testing is skipped, which creates risk. Now, this may be enough to convince our stakeholders, since automated tests run faster than manual tests. But if they're still not convinced, we can also estimate test automation ROI. So ROI is the result of savings gained divided by costs. And it can be modeled by plotting a curve of estimated ROI over multiple test automation runs compared with a break-even line of 1. So once our ROI curve reaches break even, we've paid off our investment, and anything beyond is net savings. So some key ideas here are that there are upfront and ongoing costs to automate tests, and that the more often we run the tests alongside code changes, the more value we'll get from them. Now, since ROI is a unitless number, it doesn't matter if we use dollars, yen, or even time, as long as they're the same for both savings and costs. So for ease of calculation, we'll use time as our currency. Now, at this point, I'll urge caution. ROI is difficult, if not impossible, to calculate because there are many factors that go into calculating savings and costs, and these can vary widely from project to project. But the good news is we can still estimate and communicate ROI by focusing on a minimum set of factors. So our goal will be to keep the model as simple and generic as possible so that it's easier to learn and widely applicable. So to estimate ROI, we'll estimate time saved by replacing manual tests with automated tests, which brings another point of caution. There's a common trap that many organizations fall into that we want to steer clear of. It's natural to want to use a set of manual test cases as a checklist for creating UI level end-to-end or E2E tests. But that's a problem for several reasons. In particular, E2E UI tests such as Selenium or Cucumber tend to be slow and fragile compared to lower level tests such as unit and integration tests. They tend to intermittently fail and take time to investigate and troubleshoot. Now, this can stop teams from using the framework because it becomes too slow or difficult to maintain. It's better to replace manual tests with a combination of unit and integration tests, as well as a few E2E UI tests where needed. Unit and integration tests tend to run faster and more reliably, while the E2E tests provide the most application coverage. Also, good testing includes manually exploring the features while executing test steps. Exploration helps find unknown regressions, and it's not something that automated testing can replace well. So any automated regression testing strategy should still include exploration as part of testing new builds. So let's show an example. First, we want to estimate our savings. So if we replace 100 manual tests, they no longer need to be run manually. And if these tests normally take an average of 5 minutes to run each, that's 500 total minutes of manual testing time saved. So if we then estimate that the total time to run any number of unit integration and E2E test suites adds up to, say, 50 minutes, then our total time savings would be 450 minutes per run. Now we'll estimate our costs. We'll start by estimating the time it takes to build our automation framework, and say it took an engineer 2 weeks or 80 hours. It doesn't include time for creating the tests themselves. If we had bought an automation tool instead of building it, we could estimate the cost of the tool in terms of engineer hours. Next, we'll estimate the total time it takes to write our automated tests. We'll say 50 hours for each type of test for a total of 150 hours. Finally, we'll estimate the time it takes to maintain failing tests. Most of the time this is 0, but when there are failures, it can take hours to fix. So we'll say it averages out to about 1 hour per run. So our total estimated costs are 230 hours to build and 1 hour per run to maintain. Now, using estimated values, we can create ROI estimates for different scenarios. And the good news is we have a tool that will take our estimates and visual ROI for us over time. So in our example, we replaced 100 manual tests with automated tests. We estimated that manual tests take 5 minutes each to run on average, and that the total time to run all our automated tests is 50 minutes. We estimated that manual tests take 5 minutes each to run on average, and that the total time, to estimate costs, we said that it would take 2 weeks to estimate costs, we said it would take 2 weeks for our developers to prepare our automation frameworks, and eventually 150 hours to replace with automated tests. We also estimated an average of 1 hour of time per run to analyze and fix failing automated tests. So in this case, we would estimate an ROI of about 2.7, or nearly triple our investment, after running our test 100 times, breaking even at about 45 runs. Now, let's say that we checked with our estimates with our engineers, who say that 2 weeks is not enough time to create our frameworks, and that 4 weeks would be more realistic. Now, according to our estimate, we break even at around 60 runs instead of 45 after 100 runs, but still estimate an ROI of 2.1, so more than double our investment. In the last scenario, the test automation suite never reaches full ROI because it stops being used after the 30th run. The project was canceled, or the team stopped using the framework for some reason. In this case, the ROI is just 0.43, meaning that 43% of what was invested would be earned. So 57% of our effort was wasted. In this case, it would be more cost effective to just run all manual tests and never do automation. While we can't control things like project cancellations, we can plan to build fast, durable test automation frameworks that'll be used for as long as the product exists. Oops. Sorry about that. Okay. So again, we've tried to keep our model as simple as possible. Yet there are many factors that have not been included, such as ones listed here. As you create your estimates, you'll probably think of even more factors to include that are relevant to your product. And that's perfect because this model is just a starting point. So in summary, relying on manual regression testing leads to ever-growing risk to team velocity and product release. Though it may take time and money up front, test automation is a way to reduce this risk, and the more it's run, the greater the return. It's better to replace manual tests with a combination of unit integration and end-to-end UI tests. And a model like the one we've used here can help estimate the value of test automation in a way that's visual and understandable to non-technical stakeholders. And you can download the ROI tool here in Japanese or English for free. Please feel free to write down the URLs. They'll be on the next slide as well. Or you can take a picture of it. All right, so I hope now that you have some new ideas of how to communicate the value of test automation. I'll take your questions now. And if you'd like to submit offline questions about this session or about Slalom, please feel free to scan the QR code.
Sure. Some minutes, so if anyone have question, please talk your question. In Zoom people, so you can mic on and talk your questions. Or no one have questions. So thank you for Omar. This session is finished. Finish this session. So please.